All right, welcome back. Our next assignment here, we are going to calculate oxidation charge in an ion. Now, what we're looking at in your reference tables, we're looking at the numbers in the top right of any box. Those are the oxidation numbers. And again, those relate to losing and gaining electrons. And remember, if you are gaining electrons, you're going to have more negative charges than you do protons, so you're going to become negative. If you're losing electrons, now I have more protons than I originally did, so I'm going to become more positive. So on pages 33 and 34 in the yellow booklet, that's what we're looking at. So what we're going to do is, your assignment is going to do all the questions, 1 through 24. I'm going to do 6 of them with you right here, so you'll have 18 left to do on your own. Now, the way that they write them in the booklet's a little awkward because they put the charge backwards. Like your number 1 might say 2 minus. Number 2 just says 2, that one, or excuse me, just minus. One of the other things I want to point out, if it just says minus, really it means, as we discussed in class, really it means minus 1. 2 minus really means minus 2, 3 minus means minus 3. So for example, number 12 for PO4, which is the phosphate ion, it lists as 3 minus. Really it just means it has a negative 3 charge. Okay, that's what we really need to follow. Now, what we're going to be doing is setting up a little T-chart for our math. And so what we want to do is break this up. And so if I just take and split my math up into my carbon and my oxygen, that whole thing, if we put a parentheses around it, for example, we talked about the MC-Hammer rule, where you can't touch this, we can't separate it. This whole thing, CO3, we don't need to put the parentheses through these. I'm just kind of showing you how it is. This whole thing, CO3, is minus 2. It has 2 extra electrons in it. Now, some of these you might end up having positive ions. I believe in the booklet, let me just grab the booklet here. I believe all the ones you have to do for the sake of this activity are all going to be negative. Oh, actually, sorry, you do have 1 positive, but the process is the same. You're going to try to calculate the overall charge. So what we need to do is we need to use and look at the possible options. So the only option according to my reference table for oxygen is minus 2. So again, when we were to look up oxygen in the box, oxygen is a minus 2. But when we look up carbon in the box, according to our key, carbon has minus 4, plus 2, and plus 4. So we need to know what option to actually use. So I don't know what number I'm using for carbon, but I do know oxygen is going to be minus 2. If I take those two numbers, if I know that oxygen is minus 2, but there are 3 of them, I am basically doing a multiple. I have 3 oxygens, and each oxygen is minus 2. So it's minus 2 plus an additional minus 2 plus another additional minus 2. So what we end up with is minus 6. Now, if I have minus 6 on this side, I want to add up those two numbers so that collectively they add up to minus 2. Okay? And the way to do that is basically if we just look at our math, something plus a negative 6 equals minus 2. In this case, it's going to be the plus 4. Okay, the plus 4 carbon minus 6 will add up to be minus 2. So you do have some space. You have some space. Again, we're on page 33 and 34. You have some space. So what you need to do is make your little T-chart. Then in your space, what I want you to do is write C equals O equals. So C equals, in this case, plus 4. O, okay, the 4, because there's only 1 of them. There's only 1 carbon, so it has to be 4. The O, though, don't write minus 6. Okay, the O is not minus 6. The O is still minus 2. Okay, that's the original charge. But because there's only 1 carbon, that must be plus 4. Okay, that must be plus 4. So we're going to put our final answers over here to the side. All right, we're going to go through 6 more. Hopefully it will make more sense. Then you can practice them on your own. And then again, you can leave questions, comments in the video below if you do have concerns. All right, let's take a look at chlorine and oxygen. It has to be minus 1. Again, we know chlorine by itself is minus 2. There's only 1 of them here, so this is minus 2. The only way this is going to fit to have our math total up to minus 1 is this has to be a plus 1. When I look up chlorine on my reference table chart, notice we have chlorine plus 1, plus 5, plus 7. We have a couple options to choose from. So because there's only 1, then it has to be the 1 charge. So Cl is plus 1. O again is minus 2. Okay, O again is minus 2. Notice the formulas are very similar, ClO2 and just ClO. They're both -1. And you'll notice one of your next questions. Now, notice, okay, we're on number 3 now. They look very similar. I believe number 4 is very similar as well, but I'm going to let you figure that one out on your own. We set up our T-chart. We know O is -2. -2 times 2, that means I have -4 charge. Okay, I have -4 charge overall because there's 2 oxygens, each at -2. The chlorine, again, if I want to have a total -1, again, we're considering this like this, the MC Hammer rule, the whole thing has to be -1. If I know oxygen's charge is -2, I know there's 2 of them there, -2 times 2 is -4. So in order for my math to add up to -1, this is going to have to be a +3. +3 minus 4 gives me -1. There's only one of them there, so this must be the +3 carbon. Or, excuse me, chlorine. Chlorine is +3. Oxygen, again, -2. We're doing the charge here, not however many of them. It's not the charge on the bottom. And again, chlorine has +1 options, +5, +7. Now, notice my answer was 3. Just because the answer does not appear on the reference table doesn't mean it's doesn't mean it's an option. These ones on your reference table are the ones that are most commonly occurring, but they're not the end all. They're not the final answer. Chromium and oxygen. Again, I want the whole thing to be -2. I set up my chart. Oxygen times 4. So again, if we kind of block that -2, oxygen by itself is -2. So this is -8. In order to become -8, and I have a -2 up here, this is going to have to be a +6. So if we look up chromium and oxygen, chromium, I don't know if you can see that, we'll zoom in. I'm not sure if the lighting's great. We'll zoom in chromium. Chromium has a couple options, +2, +3, and +6. So because there's only one chromium, chromium is +6. Oxygen, again, this would be a +6 up here because there's only one of them. Remember, if there's no number, really it's a 1. 6 times 1 is +6. -2 times 4 is -8. +6 -8 ends up with my whole overall charge of -2. So again, my oxygen is -2. Chromium is +6. Okay? Same setup, Cr and O, but now it's Cr and O, Cr2O7. Again, oxygen is -2, so this is -14. So I have to, this is where we really need to pay attention, okay? Oxygen's charge is -2, there are 7 of them, so -2 times 7 is -14. My whole charge needs to be -2. So if I have 14 and I want to get -2, I got to be +12. Okay, there is no chromium +12, but look, now in this case, in my first 4 examples, there was only one carbon, there was 1 chlorine, 1 chromium, and 1 chlorine. Now we have a different number here. Just like we had with our oxygens distributing that charge, I have 2 chromiums that are going to distribute the 12 positive charges. So with everything we've done before, we've done the charge times the number of elements or atoms gives me my overall charge. So I got to do the same thing over here. What times 2 gives me +12? Easy enough, +6. 6 times 2 gives me +12. So in this case now, chromium is +6. Oxygen, again, is -2. So notice in both of our answers, chromium is +6, oxygen is +2. Chromium is +6, oxygen +2. But my equations and my formulas are different. CrO4 and Cr2O7. But if we look at this one with chlorine, ClO and ClO2, chlorine was 1 and chlorine was 3. So just because you have the same element and same combination of elements does not always mean that you're going to have the same charges. So I have the same elements in these two, but they have different charges. Chlorine has different charges. And then I have the same elements in these two, but the chromium has the same charge. Okay, so every case is going to be a little bit different. All right, our last one here, and then you'll be on your own to finish the homework, which again is the rest of the 2 pages. Again, can't touch this, right? MC Hammer. The whole thing has to be -3. We know oxygen is -2, so this is a -8. I have to have the whole thing add up to be -3. So -8, we want to add up with -3. This has to be a +5. There's only 1 phosphorus, so 1 times 5 is my value. So phosphorus equals +5, oxygen equals -2. If we look at phosphorus on your chart, over there in the top right, phosphorus has -3, +3, and +5. So hopefully that makes sense. Make your little chart first. Go with your negative element maybe, and then you can try to figure out, because it's more likely the positive element is going to give you a little trouble. So looking at these, the rest of this page all have oxygen, and even many of the second page have oxygen as well. So play around with it, see what you can come up with, okay? Your homework again, finish all of page 33 and 34. You can do 1 through 24. We've already done 6 of them, okay? So you have 18 left. Again, if you have any questions, comments, thoughts, put them in the put them in a comment box below, all right? And look forward to your next assignment. Talk to you soon.